Hello everyone, I'm student Xuanyu Li. Today I'm going to introduce the development of the lattice organic light emitting diode. This is my outline. I will start an introduction. OLED is made of sound-luminance organic semiconductor materials. So OLED don't need backlight and liquid crystal. Compared to LCDs, it has the characteristic of lighter and thinner, high contrast ratio, full color, and also flexible properties. Next is the mechanism of OLED lighting. As an external voltage is applied to OLED to drive electrons and holes into the device from the cathode and anode respectively. And when the electrons and the holes are transferred to the middle light emitting layer, they will combine to emit light. At this time, it can be regarded as the molecule is in an excited state and will quickly return to the ground state and then release the energy. The amount of the light energy emitted is the energy difference between these two states. If the energy difference is large, it will emit high energy of blue light. Otherwise, it will emit yellow light or red light. Next is the manufacturing of OLED panels. OLED panels require a fine metal mask, which is called FMM, to control the arrangement and resolution of RGB colors. As shown in the figure, organic materials will be evaporated on substrate, which the fine metal mask will accurately control the size of the deposition. And the size and accuracy of FMM openings are directly related to the yield of the OLED panels. And next, I will introduce the JDI company that released the global #1 technology in OLED manufacturing. JDI Company. The whole name is Japan Display Incorporation, which is a display manufacturer in Tokyo. And it has many branches that are located in Taiwan, China, Korea, Germany, and USA. It was established in 2012, and at the beginning, JDI was composed of 3 major Japanese electronics companies, which are Sony, Toshiba, and Hitachi. They produce multiple products, such as smartphones, tablets, cameras, automobiles, and other electronic devices. JDI is one of the leader display company in the world. Next, I'm going to introduce the JDI company that they released the newest OLED technique, which is called ELEAP. ELEAP technique is called as environment positive lithography with maskless deposition, extremely long life, low power and high luminance, and any shape patterning. Primarily, it uses the lithography process with maskless deposition to evaporate organic materials. The biggest advantage is that this technique don't need to use fine metal mask to deposit organic materials, as mentioned before. OLED pixels are generated by photolithography, and the manufacturing process can also reduce the material use and carbon dioxide emissions. ELEAP techniques can increase the emission efficiency up to 60%, and which is 2 times peak brightness, 3 times long lifetime compared for conventional OLED panels. And it also has the free shape flexible designs. Next is another newest OLED technique, which is called HMO, and it is also released by JDI. The whole name is High Mobility Oxide, and it is an oxide semiconductor technology used for display panel backplanes. Its electric field effect migration characteristics are more than 4 times than the traditional oxide TFTs, and it will inherit the high resolution and high update rate characteristics of low temperature polysilicons, and it combines it with the lower power consumption characteristics of the traditional oxide. JDI's new OSTFT technology generates high mobility, and which have the twice of the field effect mobility of conventional OSTFTs, and ultra high mobility oxide semiconductors, which is called UHMO. It have the 4 times higher field effect mobility than conventional OSTFT. Moreover, HMO enables the same level of on-current flow as traditional LTPS, but it can maintain low off-leak current. These semiconductors become a new generation of revolutionary products, and also the stable HMO. And also, this stable HMO mass production technology has been verified by JDI. Next, I'm going to talk about the advantage of HMO technique. And for ultra HMO field effect mobility on JDI's G6 mass production line is about 52, and it is an extraordinary high level compared to conventional oxide. And a further advantage of HMO is that while conventional high mobility AMOLED backplane required LTPS technology, and it may limit glass substrate size to G6, but HMO can be used in G8 or larger production lines. And JDI believes HMO will drastically accelerate display technology innovation and contribute to significant improvement in both OLED and LCD display performance. And it's including lower power consumption. And for VR or AR displays, it will have higher resolution and higher update rate. And for transparent displays, they can obtain higher transparency and higher quality image for the larger size displays. Next is the potential development. According to JDI's website, it can reduce 150,000 tons of carbon oxide emission per year. It means that this technology is eco-friendly. Also, the Tech News magazine reported that Samsung visited its equipment supplier, which is Applied Materials, in the US, and they going to discuss the JDI's ELIP technology, and also discuss micro display or display panels under 1 inch with applied materials. And it can be considered that Samsung was interested in ELIP techniques of manufacturing OLED panels. And JDI also claimed that ELIP techniques is possible to be used for G6 as well as G8 OLED panel production in 2024. And ELIP's addressable market can be used in multiple display applications, such as the panel resolution are ranging from VR, smartphone to TV monitor. And this is my reference. Thank you everyone.